So here.
There we go.
Okay. All right. So welcome everyone. Today we are so excited. Actually, it's our privilege to have our Professor Bill Selby come here to talk about severe weather and climate change. And you have a lot of time to ask questions you're afraid to ask. For example, you're afraid to ask Jane, right? Because she's the teacher. She's going to, give you the grades, the points. You don't want to, make her mad, right? But you will never do that, right? But Bill is here, okay, and he's an expert in meteorology and on the topic of climate and climate change. Okay, so feel free to ask Bill any questions you have been so curious about it. Okay,
Yeah,
and
when we're done, you'll know that I'm not an expert at all, of course, because I won't be able to answer the questions.
you are, because you have a blog just specifically on California, not California and many other things about California, and you have a lot of posts on weather and climate, right?
Quite a few, yeah.
So let me share the screen, guys. This is Bill's post. Okay. Where it is? Okay, let me just share the computer sound. Okay, share. Do you guys see my screen? Yes? Give me a
Yes,
thumb
so
up if you, yes. Okay,
I'm looking at my website right now, and right? Is that correct?
yes, yes,
Okay,
yes.
there you go.
So this is Bill's website, Rediscovering the Golden State. Okay, so Bill actually is not just an expert in meteorology and climate change. He also know everything. I will say, it's the only person I know everything about California. So ask him about those questions. He know every single place in California, people. I'm serious. So if you're curious, you can go ahead to read those blogs. And Bill is a geographer. Bill always think spatially. So he is our special guest.
Did you say spatial guest?
Spatial, also special. Because you are spatial, you are special. Okay, so well, I will ask let Bill to introduce himself and also maybe give us few guidance how to explore this his website.
Yeah, so my name's William Selby, and I taught at the college for over 30 years. So I'm an old guy now.
No,
And
you're not.
it was the best job I ever had. And so, after 30 years, they put you out to pasture, which is probably a good thing because it opens up other chapters in your life. And I think it's good that the students are exposed to new faculty with some really fresh ideas. And of all the people I could ever think of, Jing is like the perfect replacement. She's like three people in one, and they're only paying one person to do all of her work. It's pretty amazing. Anyway, yeah, we used to have great times at the college. I taught the weather and climate class and several other geography classes. One of my favorites was our field class. And though you can't do field classes right now, I really believe in applying this knowledge, applying what you learn in the book and also in the classroom to the real world. And field work, I think, is very important. I hope that all of you, when you read something in the book, you can walk outside and look up in the sky and sense what you've been reading, or perhaps, interpret what's going on in the atmosphere. Is that okay? Am I doing okay, Jean? Is there
You're
anything else that you wanted from me, or?
you're doing great.
Okay, so is that it? Can I go now? No. Okay. Well, it sounded like, do you want to jump right into the substance, or is there, oh, my website. So yeah, we started what happened is we were teaching this class called The Geography of California many, many years ago. And I felt there was no really good book to go with it. So I wrote one and gave it to my students. And eventually we worked out a deal with Wiley Publishers. And our book right now is in its 4th edition after more than 20 years. And it's great because Wiley is able to offer it online for only like $25. And I'm really appreciative of that because I know all you students are trying to make it day to day. Some of you aren't even. And so that really helps the students who want to learn a lot and not spend a fortune doing it. Anyway, we have a free website that goes with the book, and this is it. And you can just use it, you know, anytime you want. Share it with your friends and family, and there's all kinds of interesting stories on there, not only from me, but from people like Jean. And hopefully we're going to grow this website as some of you continue to add to your knowledge base. You might think, hey, I got a story that could go on that website. Let me know, and maybe we can put it up for you. It has to be California, though, because that's what our project is all about. It's a big project. Maybe one of you will be running this project someday. Who knows?
Thanks, Bill.
And they're thinking, well, that was a weird thing to say. That's just the start.
Okay, so people, I shared the, I shared the website in our chat box, and Juan Lotus have a question for you, Bill.
Oh, good. What's the question?
So, how many wetlands are left in California, and do you utilize them with your field work?
How many what bands?
Wetlands.
Badlands. How many
Badlands.
badlands are left in California? Like B-A-D, badlands?
No, wetlands.
Could you spell that for me?
W, let me here. Wetlands.
Wetlands. Oh,
yes.
That's a great question. Although it does not directly connected to the weather and climate of California. That's all right though. Yeah, we've lost roughly 95% of all the wetlands that we originally had in California. And the reason for that is that you will notice that most of the wetlands are in prime locations with the best weather. People want to live near the beach, near the coast. And then what happened to many of our wetlands also is that they're perfect locations to scrape up and make boat harbors out of. And so we did that. One of the best examples of a few wetlands that are left, of maybe that 5% that are left, is the Bayona wetlands. And of course, that's just a small remnant of what once was. And also go up to Malibu Lagoon. That's a pretty interesting place where the Malibu Creek flows into the beach there, and at one of the most famous surfing beaches in the world, Malibu Surfrider Beach is there. So what I think the question was, what's left of our wetlands? And those are two local examples. If you want to see another nice one, go down to Newport Harbor and rent a little kayak there, and you can row around what's left of the wetlands there. And it's pretty impressive that so many different types of species of birds and other animals still live right near the city. Of course, one of the best places to go is toward the north, because as you get into the less populated areas, in Central California, for instance, Morro Bay is a great area to explore wetlands. And then as you get north of San Francisco, there are some beautiful wetlands that remain up there as well.
Where is that?
Morro Bay?
Yeah.
Yeah, Morro Bay is halfway between here and San Francisco. It's just south of Big Sur. And you can even rent a little boat and row around Morro Bay, and if you're lucky, a sea otter will come up and say hello.
What was the second wetland that you mentioned?
Gosh, the local ones, you can hike around the Marina Del Rey there at the Bayona wetlands. In fact, there's a bicycle path. Pardon me?
Let's zoom into that area. I'm putting a map here.
Okay. Yeah.
Ballona?
Then,
Yes.
Bayona wetlands, yeah. B-A-L-L, there it is. B-A-L-L-O-N-A. Yeah, Bayona wetlands, when you're driving on Lincoln toward the airport, it's the ocean, there it is, it's the ocean side of Lincoln. And there's a long story about how that area was saved. If you look at that whole Marina Del Rey area though, that used to be the wetlands. And they carved it up and put a boat harbor in there a long time ago, which is pretty typical of the original wetlands. So, oh look, she's on the National Wetlands Inventory.
Yeah.
Your instructor is so smart and so far ahead of the rest of us, it scares me sometimes.
Well, because she knows something about GIS, I know we can put
Yeah.
everything online.
She's amazing. Well, did I answer that question? Oh, anyway, the other really close ones that I mentioned were the Malibu Creek State Park there, right there where across from the community of Malibu. If you know where Surfrider Beach is, there's a restored wetlands there as well, where the creek flows into or toward the ocean. I was just there 2 days ago. We went swimming out there. Yeah,
And you can do the bird watching, right?
That's amazing birding area there as well, particularly in winter when the birds from the north are escaping the cold and coming down here. Yeah, and then Newport Harbor was the other one that I mentioned. That's a pretty nice one to row around. If you
Newport or?
Yeah, you can rent a little boat. Bring a friend, and you can rent a boat and you know, a kayak, or you can go. There are different ways of seeing it. There are trails all around those areas as well.
White Lotus, I don't quite understand your second question. Could you just ask Professor Bill Selby by
Yeah.
yourself? Yeah.
I was just asking, is also Madrona Marsh a wetland?
A madrone?
Yes.
Oh yes. Okay, good. We don't have them here in California because I think the one you're talking about is a tropical environment. Did I get that right?
No, Madrona Marsh is in Torrance, I think.
Okay, I know what you're talking about. Madrona.
Yeah.
All right. Yeah, you know, I'm not real familiar with that one. It's smaller than these others I mentioned, but it's in a key location because, of course, right in the middle of the city there. So that's one I should explore. That'd be a fun short trip.
Okay.
Where it is? I'm sorry.
Torrance.
To the South Bay, toward Manhattan Redondo Beach. Did I get that right?
Yes.
So farther south.
Oh, sorry. I lost myself. Yes.
What was the one in Malibu called?
It's a Malibu Lagoon State Park.
Oh, okay. Thanks.
Yeah, Malibu Lagoon.
Newport.
There's the Newport.
Yes. Laguna.
Harbor.
Laguna. This one, right?
I think she was asking about a place in the South Bay, though. That would be just north of Long Beach, on the other side of the Palos Verdes Peninsula. I believe that's the case. Did I get that right? No answer. Yeah, they're between Sunset Beach and Huntington Beach. There are some nice wetlands too.
This is Huntington Beach.
Yeah, most of those are restored and were destroyed at one point by oil drilling and other human activities, but some of them have been brought back. It's amazing how quickly nature will heal herself when we leave her alone.
So, Bill, I actually have a question on that. So, do you mean if we just stop destroying everything, the nature will restore
Yeah,
everything by herself.
absolutely. I mean, we could take ourselves off the planet right now, and you would notice a remarkable recovery. We do this all the time where we go to a place. We were working with the Park Service before I retired up in the Santa Monica Mountains and also out in the Channel Islands. And we would help with some of these restoration projects, and we'd go back, and just a year, you can see the difference. Malibu Lagoon is a perfect example. When I was out there just the other day, you would never know that that was completely scraped up and completely remodeled, hopefully according to nature's plan this time. It's quite a success story.
So we know our climate change, global warming will raise up the sea level. So how that will threat our wetlands, especially close to the ocean, the beach.
Yeah, gosh, the climates are changing, and it's affecting every ecosystem everywhere around the world. In California, what that usually means is, well, for our purposes, when we're looking at the climate change in our state, we're seeing wild swings of 1 year we'll have a very wet year and we'll flood out these areas, and the next year we're not getting any water at all, hardly. And so sometimes we'll get an in-between year. And so all of these ecosystems have to respond to that. In those wetlands that rely on snowmelt, they're even more impacted because the snowpacks are less and less reliable every year. Hey, I'm gonna sneeze. That's scary now when you hear somebody sneeze or cough. I run. Anyway, so your question was, how is climate change changing our wetlands?
Yes,
right?
Threatening our wetlands.
Yeah, the other big answer to that, of course, is that sea levels are rising. Our sea levels are up about 7 inches over the last 100 years, over the last century, and they're rising faster now. So as that happens, each storm that comes in with a high tide is more likely to destroy more coastal areas. And that includes all those, you're looking at a map there, all those houses along the beach. You probably don't want to be investing in homes on the beach right now. And but anyway, these storms are more potent when they come in now, because when they bring a little bit of a sea level rise, along with that extra 7 inches, they're able to do a lot more damage. And that includes to the natural habitats. That includes the natural habitats as well. Very complex questions.
Yeah. Well, and we know those wetlands, they are fed by those, the Malibu, the creek, which
Right.
is, fresh water. But
Yes.
here, they're, join the seawater. So when you have the sea level rise, it's definitely change the water in your lagoon, right, people? And that will totally change your, the habitat of all the, species living there.
Right. What happens is that species evolve, the species that survive are those who can withstand greater salt concentrations in the water. And then those that are freshwater species disappear or move on upstream.
Or you can make, quick adaptation on those, the salinity, the change.
Yeah.
Great. Any other questions? Thank you, Ed Lotus, for the great question.
So
okay. Yeah,
I do
go
have,
ahead.
Jean, do you have a question or something you want me to cover? If you don't, I do have a little kind of intro fill-in that's kind of fun.
Okay, sure. Yeah, go ahead.
Okay? Are you all right
Yeah.
with that?
Yeah.
Okay. Yeah. So Jing asked me, your professor, sorry, we are very informal, Jing and I. So your professor mentioned that you were interested in severe weather, which who isn't? I mean, that's what makes weather and climate exciting. and climate change and how they might be related. And so just a quick intro that you all have heard before, I think, and that everyone should know, is the climate change thing is pretty straightforward. You know, we've always had climate change on our planet, millions of years of climate change. Some of the change that we've seen over many, many thousands of years has been more drastic than what we're seeing now. But the difference is those natural climate changes occur usually over very long periods of time so that plants and animals are able to adapt to them. Unless like a giant rock hits us from space, like 66,000 years ago. That's quick, that's a fast change. The problem with the changes that we're looking at right now is they're happening very rapidly compared to natural history. And so we are having enough trouble adapting, but other organisms are trying to adapt as well. And so we think the reason for that is that there's just a little bit more energy that's been trapped in our atmosphere. And so the reason for that is that if you look at the amount of carbon dioxide in the atmosphere right now, it's more than we've had for over 1 million years. It's probably longer than that, but it's difficult to go beyond 1 million years and look at the historical content of the atmosphere because we don't have as many ways of measuring it. And that rate or that amount of carbon dioxide in the atmosphere is increasing very rapidly. Probably as rapidly as we could record if we go back in historical times long before we were around. So why is that important? It's not only, of course, carbon dioxide, but methane and a few other greenhouse gases. It's pretty simple stuff, everyone. You know, the science is not like brain surgery here. Greenhouse gases are the reason why we're here. Well, you know, they trap enough heat in our atmosphere to keep us from freezing to death every day. In fact, temperatures would be about 30 degrees Celsius colder if we didn't have greenhouse gases. We'd be, life on Earth as we know it would be impossible without greenhouse gases. And the reason for that is what you've also studied. I imagine, Professor, they've studied, and that is that if you ask someone, how's the atmosphere heated? They'll tell you, well, that's a silly question. It's heated by the sun, right? But it's a little more complicated than that, isn't it? Because the atmosphere isn't really directly heated by the sun for the most part. It's that shortwave solar radiation that comes through the atmosphere, which is mainly transparent shortwave radiation, that gets to the surface, either the land or the oceans, and it's absorbed there at the surface. Some of it is reflected, that's true. But that is really important because that initial sunlight that is absorbed at the surface is then heated. And because the sun is so much hotter than Earth, of course, what is it, 6,000 degrees Celsius on the surface? It emits in the shortwave band of the spectrum, mainly in the visible, infrared, and the ultraviolet part of the spectrum. So that shortwave energy gets through our transparent atmosphere, heats the surface and the oceans, and then they don't get nearly as hot as the sun. So what kind of radiation do they emit when they warm up? Now I'm asking questions. So the question is that when the surface of the Earth and the oceans warm from sunlight, what type of radiation do they emit? If the sun is emitting in the shortwave part of the spectrum, relatively speaking.
Okay, so Nancy said thermal IR, thermal infrared.
There you go. So those that long wave energy is then emitted by the surface, and it's trapped by greenhouse gases. So they're selective absorbers. They let that shortwave energy in, and then they absorb the long wave energy that's trying to get out. And thank you, greenhouse gases, because like I say, without them, we wouldn't be here. Earth, as soon as the sun would set every day, we just freeze over every night. Okay, so obviously they play a very important role in regulating the temperatures on our planet. I mean, this has been known for more than a century. It's not controversial. This is really easy stuff. You know, I don't know how it gets political over time. I guess I do, but we're not going to get into that. So the basic science is really pretty easy. If you increase greenhouse gases, you're going to trap more long wave radiation that's trying to get out, and that'll warm us up. And that's exactly what's happening. So if someone asks you this question, you can tell them, well, how do you think the atmosphere is primarily heated? From the top down or the bottom up? And you can let them know that it's primarily heated from the bottom up by long wave radiation, not from the top down by short wave radiation. It's that short wave radiation from the sun that gets the thing started, but it's the long wave radiation from the surface that's trapped by greenhouse gases that actually warms our atmosphere. The vast majority of warming is caused by that. Okay? So it's pretty simple. Add more greenhouse gases. How many people have ever been in a car on a sunny day, sunny, warm day? Anyone?
Raise your hand.
Yeah.
Yes.
So if the next time you're in a car on a warm, sunny day, just roll up the windows. Let the shortwave energy from the sun come on in, heat up the surfaces surrounding you, and see if that long wave energy can get out and see what happens to the inside of your car. Now that's an oversimplified and pretty crude way of explaining it, but it's fact-based. And so what we're doing right now by burning fossil fuels is that we're rolling the windows up in our car on a sunny day. And so what is happening is what we expected to happen. And these, I shared a couple of links on my website just recently. I just put it up this afternoon. And one is that NOAA website that really shows you how temperatures have been increasing over time globally. Another thing I will mention about that is that when you talk about climate change, though temperatures from pole to pole, when we measure our entire atmosphere, not just one place, are increasing, and we've had some of the hottest temperatures in history over this decade, which beat last decade and the decade before that. There's some of our local temperatures here that you can see that correspond with that trend. Anyway, as that happens, I've lost my train of thought now because I'm looking at the website thinking, wow, that's a pretty interesting looking graphic there. There's Los Angeles average temperature. We see this all over the world, but not everywhere. I got back to my train of thought. So what climate change is doing for us is pretty simple again. The long wave energy that gets trapped, we got a little extra energy, quite a bit of extra energy trapped in our atmosphere. And so nature's going to have to distribute that energy. And the way she does that is she's more powerful. The storms become more powerful, high pressure systems, low pressure systems become more powerful, winds become more powerful. And we're seeing that as well. Not only is there a gradual warming across the globe, some stations aren't experiencing it, others are experiencing it in extreme fashion, but there is an increased frequency of severe weather events. All of these are responses that computer modeling had predicted many years ago, and now it's happening. So from a scientific viewpoint, it's very exciting to watch. It's the greatest experiment we've ever run in the history of humans on Earth. But from a humanitarian perspective, it's very unnerving, of course, and tragic in many ways. And you see this on the news all the time now, don't you? The terrible droughts that have hit parts of the world where people are starving to death, and you have all these refugees that are trying to find a place to live, and no one wants them because they're suffering from climate change, and they have their own food production problems. So we're seeing this across the world, around the world, and you know, sadly, it shouldn't surprise anyone. The science is pretty clear on this. Unfortunately, politics and economics get involved, and people start debating things because they don't want it to be true, and I understand that. But that's what's going on. Any questions? Anyone want to add to that? Jing, you want to add to that? Or
one thing when I'm exploring your website, this new post, I noticed that for LA, this is LA people. You can see we run this average. You know, you can see LA actually have an increasing temperature.
Yeah.
Average from 1877 to 2015. And you can see correspondingly here, our precipitation, you can see actually slight decreasing. Is that right, Bill?
Yeah, and so I think that the temperature we went a little bit past 2015, a few years more than that. It's just not labeled yet. But yeah, so we've seen this in California. It's a very interesting trend where average temperatures have been gradually increasing if you look at the long-term average, and average precipitation has been gradually decreasing. And that's not what we want because, of course, the increasing temperatures are causing evapotranspiration rates to increase as well. And this is drying out plant communities and ecosystems much faster. And the problem with that is that if we're getting a little bit less precipitation, then you have a lot of this climate change is sort of compounding, if you will. There's a synergy involved here that's, here's some examples in our state. Between 2010 and 2016, the National Forest Service counted over 100 million trees that died in our forests of California because of drought and then the bark beetle infestations that followed it. And so these are trends we're seeing all over the world. It's not just here. And then now the other thing you see when you look at average temperatures going up and monthly precipitation gradually decreasing is that you recognize that our snowpacks are decreasing. And those snowpacks are important, of course, because as they melt gradually, they not only feed the streams that feed ecosystems below them, but they also eventually run into our water projects. And during the summer months and the fall, we really rely on those water projects that are fed by those less and less reliable snowpacks for our water supplies. And the other thing you saw in those graphs is typical all over the world, where you see these wild variations from year to year that seem to be getting more and more severe. And that certainly has been the case in California, where we'll have a year or several years of drought, historic drought, and then we'll have a year or two of historic floods, like we did a couple of years ago, where our dams fail. You know, and so one year we're worried that it's never going to rain again, and the next year we can't wait for it to stop, unfortunately. But these long-term averages, for those of you who are into statistics or you're statisticians, are really interesting to look at that dotted line. It's not easy to draw a dotted line when you see that kind of radical change every year. So this again, but all of this is what we would have expected if you would have said, 50 years ago, what if we just add a bunch of greenhouse gases to the atmosphere? What do you think is going to happen? This is probably it. It's pretty good science.
Yes, indeed. And
Oh,
Bill, actually, we had a few questions for you in the chat box.
Good.
Okay,
Go for it.
so one is from Norman, and he is asking, what are the main difference between climate change and global warming? We always use those two terms, interchangeably. So could you explain that?
Yeah, it's again, good question. It's pretty straightforward, like you might expect. Going back to our discussion, because there's more heat trapped in the global atmosphere and high and low pressure systems are churning a lot faster and are becoming stronger, that what we find is that some places aren't getting hotter at all. Some places, in fact, could actually be getting colder. Now, is the average warming? Absolutely. Is there more heat trapped in our atmosphere? We can measure that. All of our graphics, all of our data shows that. But here's an example. As Greenland, most of you know that Greenland has a huge ice sheet on top of it. Well, guess what's happening to that ice sheet?
Melting?
It's melting. Yeah, right. And as that ice sheet melts, if you look on a map, it's really fascinating. As the ice sheet melts, it sends fresh water down the side of those glaciers, and that flows down into the ocean south of Greenland. That in turn, because it's fresh water, it's not going to sink down into the ocean. Fresh water is less dense than salt water, so it stays near the surface. Wow, you're doing a great job here, Mike. I wish I had a professor like you when I was in college.
I try
Anyway,
to bring the maps, you know, because
there's,
people always wonder where are we.
yeah. You know, as a geographer, by the way, I always loved flying over Greenland. The first time I did it, I think I was in a study abroad program teaching the class, and it happened to be a clear day. And it's like you look down and you think, are we on the same planet? Because all of these glaciers. Anyway, if you could see this water that's flowing off of these glaciers as they melt is flowing into the ocean. It's less dense than the salt water, so it stays on the surface. And as it flows south, it blocks the Gulf Stream. Now, the Gulf Stream is that warm water current that comes up the East Coast. They're on the other side of their high pressure system on the East Coast. They're on the opposite side of the continent, of course, and so they get a warm water current. We get a cold one. As that warm water current moves up the US, it veers off and it moves toward England. So, and Northwest Europe. So if you could imagine, and we're afraid this is happening now, that Gulf Stream gets cut off because the fresh water flowing out of Greenland blocks it, and it doesn't make it to England or it's Northwest Europe. And so instead of their climates being relatively mild for their latitude, look how far north they are. The reason why they're relatively mild is because the Gulf Stream takes a trip up there, and by the time it gets there, it's much warmer than it should be for that latitude. Anyway, that keeps those climates relatively mild. If you cut off that jet stream, or excuse me, if you cut off that Gulf Stream, those areas are going to freeze. And so there's an example of a place that could actually get colder as the rest of the globe in general, as the rest of the Earth warms up. Was that a really long answer to a really easy question? I don't know.
You actually answered another question already from Yuri. Are there any countries where temperature are descending because of climate change?
And that so far that's been real spotty. So I can't say that that trend I just mentioned that could happen is happening in Northwest Europe right now. In fact, it's not, as far as I know. But we do see that there are year-to-year variations that are pretty crazy. An example would be this year, the north part of Asia is a much warmer they're warming up faster than anybody for whatever reason. And this seems to be moving around quite a bit. You know, 1 year or 2 years in a row, maybe we'll have European records where they'll have just one hot day after another throughout the summer and in the winter. This year it's been the northern part of Asia. Sometimes it's the West Coast. And so are there particular places that are getting colder on a regular basis? I'm gonna say I don't know the answer to that, and I don't know of any. And by the way, part of the reason for that is almost everywhere on the planet is getting warmer. There are a few exceptions to that. There are a few, but not many.
Great. So in general, everywhere got warmer.
Yeah. Oh, I can see the questions now.
Yeah, I realized I can paste that on the screen.
Oh, that's nice. You know, that first question though, I hope I answered that properly. You see, what's happening with global warming, sure, is the atmosphere is holding more heat in. And so that's what we call global warming, but that doesn't mean everyone's going to get warmer. And so that's what climate change is. The climates are changing all over the globe as nature tries to respond and to distribute this extra heat. She's got to do it. And she's going to do it in really spectacular form sometimes.
And here's another question, actually coming back home. Talking about Los Angeles, is there any specific reason why our rainfall season is completely decreasing year to year?
Okay, well, first of all, let's omit the word decrease completely because that scares me. But it also suggests that there's no variability to it, which there is. Here's a theory, okay, to try to explain this general trend. Have you all explored the general circulation patterns in our atmosphere yet? You know, where the equatorial low and the subtropical highs are? Okay. Now, you all can look at a side view, for instance, of those general circulation patterns. And what I want you to imagine is if you inject more energy into that system, then all of those weather patterns, all of those airflow patterns are on steroids now, all right? That's what's going on. So what would you expect? If there's air rising at the equator in the equatorial low, which produces tremendous amounts of precipitation, that warm, moist air that rises, would we expect to have more precipitation there? That's exactly what's happening. And in areas where, for instance, in the subtropical high, where high pressure systems dominate, where that air comes up and it begins to sink down at 30 degrees north and south, in those subtropical highs, it appears that those areas have become, it doesn't appear, it has become drier. And that makes sense too, because if those circulation patterns are now energized, then where we used to have a lot of rain, we'll get a lot more. And where we used to have a lot of drought, we're going to get a lot more. That appears to be happening globally. There are some exceptions to that, but generally speaking, that's what we're seeing. So the question was about Los Angeles. Of course, the dominant pressure pattern you've learned about that rules in Southern California is our East Pacific subtropical high. That protects us from storminess most of the year, and particularly this time of year. And as that high becomes bigger and more energized, it stands to reason that our precipitation levels may drop over time. And that seems to be happening. Having said that, when that high pressure system moves, and it does occasionally, we did a couple of years ago, all hell breaks loose. You know, we get our atmospheric rivers, we get tremendous downpours. Again, this is nature trying to work with that extra weather, with that extra energy. And I don't want to overemphasize this. There's always been crazy weather patterns and you know, violent and severe weather on our planet. It just appears to be becoming more and more likely that that will happen in most places. You know, I love that map that you've got up, by the way, Jing, because you can see if you can imagine that big high pressure system, you know, go out 1,000 miles or more out toward Hawaii. And that big high pressure system dominates up there just north of Hawaii. And in that blue space, I can see it. And you can see the water currents circulating around it. All of those water currents are propelled by the winds, right? Wind blows from high pressure to low pressure. And because the earth is spinning, the Coriolis effect will turn it to its right. Can I just mention something? This is a little trick you can learn about winds. And it always confuses my student. Remember to say that wind wants to blow from high to low, which it does, but it's turned to its right, not your right, because that will confuse you, okay? The wind is always turned to its right in the Northern Hemisphere. There, Jean, thank you. There's the high. And so as the wind pours out of that high pressure system, it propels that cold water current from, well, you know, way off the coast of Canada, all the way down to Baja California. And I know when I went swimming the other day, and you got to go out there, it's so refreshing. We have that cold water current, which is just the opposite of the East Coast, like I was saying before. Follow that cold water current around, watch it flow by Hawaii, and then it comes up east of Asia. And then they have a warm water current, right? So if you can see that these pressure patterns, if these pressure systems become more powerful, then it's that high pressure system that protects us from rain. It's that cold water that's coming down our coast that stabilizes our weather. Remember, cold air wants to settle. It doesn't want to rise. And stable air means no precipitation or storms. So it stands to reason that maybe our climates here are getting a little bit drier over time on the average, with these wild variations from time to time and year to year. Does that help to answer that? And by the way, most Mediterranean climates are experiencing this, unfortunately.
Bert, do you have any follow-up question?
No, that was a good answer. And I kind of relate on the incidents happened in 2016.
Yeah.
Remember that year we had a lot of rainy seasons, and then we break the drought season like after like 5 years, I believe so.
Yes.
And then everything makes sense afterwards. Thanks for your brief answers, actually.
Yeah, you're right on target with that. Boy, he's good at this. He remembers, you know, and when that high pressure system checked out for a while, it really opened the door for these powerful storms that were sweeping out of the Pacific coast that usually miss us. And we luckily filled our reservoirs. Unfortunately, some of the reservoirs got so full that the dams failed, like up at Oroville. And we came, by the way, that year you're talking about, we came within 1 hour at Oroville Dam of a 30-foot wall of water that would have annihilated 100,000 people. 1 hour. That's how serious that flooding was. In one of our conferences, we got to, up at Chico, we got to talk to the folks up there who run that dam, and they had the local sheriff come in and tell us the story. It was pretty nerve-wracking. He claims that they evacuated more people in the shortest period of time in the history of the world to get them out of harm's way. Luckily, the dam didn't fail, but it really, the spillway came close. And again, it's just another sign. There it is. That's what it looked like after that flood year. That's the spillway. And you can imagine what a disaster that would have been had, there it is, had it failed. It's, there's the Oroville Reservoir that was full. That thing filled up within hours, by the way. They were fixing it about 1.5 years ago. They repaired it now. But that cost us billions of dollars. And this is something that we forget about, that besides the lives that are being lost through climate change and these wild weather swings, we're paying in the pocketbook too. It's you know, billions upon billions of dollars every year in fires. And you know, you probably heard about Paradise and Santa Rosa in the last couple of years, and in these water projects that are failing. We built those water projects for 100-year floods. And it's hard to determine what a 100-year flood is now when you have a moving target. That's changing all the time. It's pretty exciting from a scientific standpoint.
Yes.
Yeah.
Let me try to find that the fire blog you have there.
There's a historic California firestorms puzzle.
This one? Yes.
It's the one with the big smoke cloud coming up over Malibu. This was just an update that Rob O'Keefe did. You know, I think your students are so accustomed to seeing this now, they just see it as, oh yeah, another fire. You know, and it hasn't always been that way. It's our fire seasons start, generally speaking, I've started earlier and later. and gone later. By the way, I wanted to mention when you go online, there it is. In this article, I try to describe what's going on that's causing these really severe fire seasons. And again, we've always had fires, but we've never had these firestorms that wipe out so much forest at one time. And you know, the fire crews will tell you this. When you talk to the veteran firefighters around the state or the western states, every year they say the same thing. We've never seen a fire behave like that before. And it's you know, just another sign that things are changing and we have to adapt to those changes. I don't know if did we veer off of the course of those questions yet, or?
Yes, I remember in one of our workshop in NWS, National Weather Service, people list out the top 5 largest wildfire occurred in California that occurred in the past 10 years. You have the top 5.
Yeah, and then if you consider that you know, again, the warmest years in the history of the world have been during this last decade. Again, every decade beats the one after it. And California is no exception. We're, you know, gradually warming up as well. And you begin to see that there's a combination, there's a synergy of events going on here, of things happening that are going to make your lives really exciting as time goes on. Oh, and I wanted to mention something else. Thank you for putting that up again, Professor, because one of the things I tried to do is pick out those weather stations, except for Los Angeles and San Diego, that were not being influenced by the urban heat island effect.
Oh.
Because when you look at the bigger cities, LA and San Diego are examples, you see really obvious warming. I mean, you look at that curve and you go, oh my God, we're gonna fry, you know? But then when you go away from those major urban areas or where urban areas have grown and you're in the rural areas, you still see the warming. There's no question that there's, you know, gradual warming going on, but it's not quite as severe. So I think there's a combination there in Los Angeles. Pasadena would be another example, where not only has the global warming been having an effect on average temperatures here, but the urban heat island effect, as we built these cities out, has also been warming the temperatures in a local level. Combine them and you've got these really dramatic curves. I was kind of surprised when I saw this one, by the way, several of them actually. So what I tried to do in this story is I picked out some of the stations that haven't been urbanized, you know, places like Death Valley and Needles and Cuyamaca, and you see that signature again. It's still there, that warming signature. It may not be quite as strong, but it's still pretty obvious.
Yes, so people here, you can see from this Professor Selby's post, it's pretty straightforward. You have, you know, increasing temperature, you have decreasing precipitation, and therefore you have more and more severe, you know, the wildfire season, right? So that is basically you know, the consequences here. That's explained why the top 5 largest wildfire occurred in California occurred in the past 10 years. Okay.
If I can just add to that too, this year, and I wrote about this in the previous story, this year has been crazy precipitation. I don't know if any of you remember, but January and February are supposed to be our wettest months of the year. That's when our rainy season really kicks in. And that's when we get that snowpack. That's when we get we get our streams flowing. But what happened this year? The Bay Area, all the way to Sacramento and down to Central California, received 0 precipitation in February. That has never happened in the history of California, ever. And Northern California was just parched by this this drought that occurred in January and February, our most important months when it comes to getting rainfall in the state. In Los Angeles, Southern California, in fact, something really weird happened too. We started a good rainy season in November, December. In January, it stopped, it shut off, and February pretty much too. And then in March, it started raining again. And we caught up with our average annual rainfall totals for the year by April. It was like a March miracle that we never saw before, because we thought we were going to have this horrendous fire season already. And that fire season was quelled quite a bit, the early fire season, by those late rains. And if anyone got out to the desert, I know I did, in the spring, you saw the results of that, because it was quite a beautiful flower bloom out in our local deserts that responded to that heavy rain of spring. So again, we had this bookmarked weird rainy season in Southern California. Fall and early winter, we got rain. The middle of our rainy season, no rain. And then in spring, we got rain again. And in Northern California, they didn't get those spring rains. And so what we ended up with, the Bay Area is supposed to get twice as much rain as we do. It's reversed this year. We got twice as much rain as they did. So go figure. It's pretty exciting.
It is. And also, it's so bizarre sometimes. You feel that way, right?
Yeah. Yeah.
So here's another question, Bill. Can you see that clearly on the back?
Yeah, can I read it? Should I read it?
Yeah, so here, let me change the color maybe.
Is it possible that climates are shifting? I might be getting old, but my eyesight's pretty darn good still. Is it possible that climates are, there it is again, are shifting across the globe? Example, one place becomes arid and another place becomes more Mediterranean. Yeah, so again, this is kind of related to what we were talking about. If you go near where those subtropical highs dominate, you'll see that places that were arid have become more arid, and places that were semi-arid have become arid. And this has been happening in California too, by the way, quite dramatically. If you consider in the state of California what controls our climates, elevation's a big factor for obvious reasons. As we get higher in elevation, it's cooler. And we also get more precipitation because mountain ranges tend to force air to rise as it flows over them. That rising air condenses and cools, and then you get heavy precipitation over mountain ranges. But here's what's going on. Our climates, because they've been warming gradually, we've seen a shift in elevation of climate regimes. An example, if you look at the Western Sierra Nevada mountains, we have plant communities that live in particular microclimates. Those plant communities are measurably now, biologists are showing them to be creeping uphill. Dry grasslands are moving up in higher elevations, replacing oak woodlands. Oak woodlands are moving up to higher elevations, replacing pine forests. Pine forests are moving up in higher elevations, replacing fir forests. And even the tree lines are moving up to 500 feet elevation so far, more in some places. It's another sign how plant communities are responding to climate change. But just to get back to that question, so particularly if you go to North Africa and around the Mediterranean, you see these places that normally had marginal Mediterranean climates versus arid desert climates. And you see that the deserts have been expanding very rapidly. And the Mediterranean climates are shifting as well toward the north. And again, it's one of the many manifestations of climate change. I want to add something. If someone comes to you and says they know what's going to happen next, and I don't know any really good expert out there, climate or meteorologist expert, who will say this is exactly what's going to happen. But we are seeing these trends that were predictable, that were predicted, actually occurring now. And the trouble is we've never run this experiment before. And so we don't know what the outcome is going to be, except it's going to be really exciting. Did I answer that question?
Sort of. I guess I kind of asked it in a weird way. What I was really trying to ask is like, do you see maybe, this is just an example, Los Angeles losing its Mediterranean climate, but that Mediterranean climate shows up somewhere else and still has a balance? So like it wasn't completely lost.
No, so if it goes according to plan, you know, what the models are showing is all of these, because we go from wet in the north to drier toward the Mexican border, all of these climates are shifting north. Just as they're shifting uphill in elevation, they're also shifting north in California. So that, for instance, the Central Coast is getting a drier Mediterranean climate. We are beginning to evolve into a semi-arid climate rather than a Mediterranean climate. And then San Diego is becoming more arid over time too.
Okay, so if these,
you know, yeah.
So if these climates are shifting up north, what does that mean for us? Like, is it just we should pack up and move and go back to our Mediterranean climate, or is there severe detrimental reactions that are going to be caused by this shift?
Well, it's interesting that you asked that question, because that's exactly what refugees are doing right now, aren't they, around the world? Seriously, those folks who have lost the ability to farm because their climates have changed so radically, and they're not producing the crops they need to feed their families, are trying to make those shifts. But there's no place for them to go because there's people who already live in those places they want to go to. And so, no, I'm not packing my bags. I'm sticking around. Yeah, I think it's fair to assume that what's been happening will probably continue. And that means that, again, in a place like California, the climate, the microclimates seem to be shifting uphill, and again, from south to north. Again, like, you know, who knows, next year, we'll get a complete pattern shift because nature is on the warpath here, and she's gonna show us who's boss. Just when someone like me thinks they know it all, she throws you a curveball.
So, climate refugees.
Professor, I wanted to add some question relating to elevation, because so at this point we are like facing like warm kind of like weather, like climate change, right? Global warming and everything. So we know that the two poles on the Earth, on the globe, have like the coldest kind of weather, right? The poles on the Earth, and they kind of happen to be colder than the equator, like the equator lined countries, right? But like even the equator countries and high elevation get like some snow within that equator, right?
They get some, what was the word?
Like snow, like
no, yeah. Yeah, you have to go, of course. The closer you get to the equator, the higher in elevation you have to go to find snow. Right? Like maybe you've been to Hawaii. At the tops of those volcanoes get snow.
Right. So does elevation even like, is elevation a biggest factor for like a weather change? Because like, what if we go like the around way? What if the Earth is like getting colder, and you know we have to maintain this like you know hot weather within our environment? Like what is it like to be, if we go around like the other side? Like what if all this,
Huh?
like, the equator got frozen and then the poles are already frozen, and then what is it like life would be at that point? Because if there is high elevation, and then if this climates are like moving around the globe, and then what is the next level then at that point?
Yeah. Well, okay, so you asked a really big question there, and I don't think you've covered the chapters on climate and climate change yet. Did I get that right, Professor?
Right, we haven't got to that point yet.
Here's what you'll get from that discussion to just introduce it. If you look at the climate controls, or what controls weather and climate on the planet, you start with latitude, right? That general circulation pattern is the most important there, where you have your equatorial lows and subtropical highs and subpolar lows and the polar high as well. Those are there because, of course, you have a lot more energy near the equator and a lot less near the poles. So there's a latitudinal consideration. Second to that, I would put land versus ocean. If you have a continental climate, which means that you either live in the middle of the continent or the air masses you experience come from the center of the continent, then you're going to have extremes. Very hot summers, very cold winters. If you have, of course, a marine climate or a coastal climate, then your climates are moderated. The summers are cooler and the winters are warmer because water doesn't heat up as fast, nor does it cool off as fast as land. So we've got latitude, we've got land versus ocean, and then I'd put elevation in that list there, just as you mentioned. Of course, it's colder as you get higher, warmer as you get lower, generally speaking, inversions put aside. And generally speaking, we get more precipitation at higher elevations. So those would be the big three. After that, I think ocean currents. If you're a coastal climate, ocean currents play a huge role. Anyone who's been to the East Coast knows how very different that climate is from ours, even at the same latitude. South Carolina, South and North Carolina is the same latitude as California. And do you know that their average temperatures for the year, their average annual temperatures are the same as coastal California? Are those the same climates though? No. Why? Extremely hot summers,
More humidity.
more humidity, and much colder winters than what we have.
Yes.
And the reason for that is that being on the East Coast, they get that warm ocean current, that Gulf Stream that comes up. So when they get a sea breeze, it's warm and humid, very muggy. They get hurricanes and tropical storms, and we don't here because our water's cold. But the other thing that's going on in the East Coast is the prevailing winds at our latitude drift from west to east, and so do the pressure patterns. And so where do our winds and pressure systems usually come from here in California? The ocean, moderating our temperatures. But where do pressure systems and winds often originate? In the East Coast, off the land. Very warm summers and very cold winters. So getting back to your question, we started with latitude, and we went from there, land versus ocean. From there, it's elevation. And then I would argue that ocean currents play a very powerful role in changing climates as well.
What about, what about the daylight effect, a location getting the sunlight?
Right. Okay. Yeah, good question. I'm going to cheat and say that was under the category of latitude, right?
Okay, so
yeah,
I'll put that in there.
Right, because when you're near the equator, you're going to get real direct sun. The sun's almost straight up in the sky many days. Right. And as you get farther north, the sun's at a much lower angle and spread over a larger area. And so it's not as intense. And of course, that's why temperatures don't get as hot, usually, as you go far north and far south of the equator. All right.
Okay, it looks like you guys can predict the questions. So the next question that is, among all these factors, which one you consider is the most important? What would you consider to be the major factors affecting climate change right now?
Okay, first is nature, right? There's always natural climate change, and there always will be long after we're gone. And so there's going to be glacial periods, there's going to be warm periods, but those take thousands of years to evolve and to change over time. And so here's an example. The scientists who have studied climate by the 1970s realized that it appeared in those natural cycles that we were going to go into a cooler period gradually. So by the end of last century, it was pretty clear that we were supposed to be moving into a cooler cycle in this constant oscillation of temperatures, right? And when they started looking, though, at our changes in the changes that were occurring in greenhouse gases, they realized that that was reversing what should have been a natural cycle. And that's what's happening right now. So when you say, what would you consider to be the major factors affecting climate change right now? There's a term we have for this. It's called the Anthropocene. Has anyone ever heard that before?
No.
Hello, Anthropocene. What does that imply?
Humans affect climate.
Right. That the greatest change agent on Earth's surface today is humans. And that is certainly true. Now, can that be reversed? Absolutely. If a big rock from space hits us, like it did, like I said, 65, 66 million years ago, all bets are off. You know? But as we look at these gradual changes that were supposed to take place, natural changes, they're not. Quite the opposite. Things are going in reverse, and that appears to be, again, because we've been pumping all of these greenhouse gases in the atmosphere. You're asking me right now, that's the key word, that's the key term there, affecting climate change right now, I'd say humans. But it's not only humans, it's just that we're the major change agent at this moment in Earth history.
Okay, so, well, speaking of that, one question from Kevin. He asked, well, how much would investing in green technology help? And also, I got another question when I read their discussion post. Do you, which one, you know, what is the most efficient way or the quick way to, you know, solve this climate change or the issues here? What we should do now?
Yeah, so it's pretty straightforward. The green technology help wasn't a science question necessarily, it's a technology question, but that's okay. Hey, stop rolling the windows up, okay? Just stop it. That's the first thing we have to do. Stop rolling up the windows of the car. How we do that is the question, right? And we want to do that in the least damaging way. We want to do it in helpful ways. And so I'll just give you an example. Everybody should have solar on their roof. There's a roof up there. It's not doing anything for you. Put the solar panels up there. That is, by the way, one of the most efficient ways of generating electricity that we know of now. 20 years ago, I couldn't have said that, but certainly is the case now. It's one of the cheapest, seriously, least expensive ways, and of course, cleanest ways of generating electricity. Why are we doing that, everybody? And I don't mean putting huge solar arrays out in the desert and destroying all of those ecosystems. Just use the space that we already have. Take control of your energy source. And that's how we're going to solve this problem. So there is one thing I will say, and I hesitate to say it, besides the green technologies you mentioned, and that is carbon sequestration. You've probably heard of that before. And what that means is we pull the carbon out of the atmosphere. That's extremely expensive, far more expensive than it would be to invest in green technologies. But we are getting there because the cost of allowing the greenhouse gases to continue to increase as they are now, record levels for 1 million years, is just overwhelming. It's going to overwhelm all of our budgets and all of our economies. It already is in many places. So I guess I'll answer the question with put solar on the roofs. Let's start there. It's cheap, it's efficient. You can get free energy from it once they're up there. And by the way, the payback on that is less than 10 years now. If you buy your solar panels, whatever you invest in them, within 10 years, the free energy you get from that, it will have paid for those solar panels, and you're going to get free electricity for at least 20 more years because they're guaranteed for 30. A lot of people don't know that because there's a lot of strange information floating around out there on the internet and in the media. Did I help to answer that question?
That's from Kevin. Kevin?
I don't see it.
So let me put that again. Kevin, are you here?
You can read it. I'll listen.
This is here.
I have a question about the carbon sequestration.
Yeah.
There are natural methods to that, right? Like soil regeneration, the soil can absorb carbon also.
Yes.
And like planting more trees in the cities and maybe grazing, will that help too?
Yeah, so we're failing on that one too, I'm afraid to say, because we're destroying forests rather than growing them. Brazil is a perfect example right now. It's a disaster what's been going on in Brazil the last year or two. And so these are huge carbon sinks, and that carbon is being released into the atmosphere now, and trees are not being replanted to suck it back into those trees. So that's one form of carbon sequestration. Taking care of the soil is another. But remember, the carbon has to get into the soil, and plants are instrumental in doing that. What I was going to mention is that some of you out there may become good enough with the technology where you figure out how to suck that carbon out of the atmosphere mechanically. Again, right now, the cost would be so terribly outrageous that we couldn't do that. But will there be a technology in the future that could do that, that humans can develop? Nobody knows. We better hope so. In the meantime, hopefully we can plant trees. The other problem with getting the plants to suck it out of the atmosphere is that this climate change is destroying plant communities at the same time. Every time I see another forest go up in smoke in California, I think, wow, there goes our carbon right into the atmosphere. So there's sort of a synergy of things happening here that are working against us that we need to reverse.
That is.
By the way, can I just mention the ocean? Because the ocean is there. There's so many things. Isn't this exciting, everyone? I mean, some of your instructors are probably not as weird as me, but I could sit and just read about this and talk about it and learn about it from all the other folks that know so much, just, all night. So you better be careful, Professor. You got to know when to cut me off. Anyway, the oceans, right now, the oceans are saving us because remember, most of the oxygen that is produced into our atmosphere comes from plants or algae that lives in the ocean. And the ocean is an enormous sink for carbon as well. It's key to soaking up as much carbon as it can, and it's doing that, but it just can't absorb carbon fast enough. And the reason is we're putting in the atmosphere so much faster than nature can pull it in. But what I wanted to say about the oceans is besides trying to save us from this, they could be what kills us too. Two ways. Number one, as the oceans warm up, not only are there glaciers melting and fresh water is being added to the ocean water volume is increasing, but the volume's increasing because when water warms up, it expands. And this is one of the main reasons why sea levels are rising right now. The other thing about the ocean is the more carbon it absorbs, the more acidic it gets. You've probably read about this, and it's a really big deal because fisheries around the world are being destroyed by the increased acidity that's being caused by the oceans absorbing this extra carbon. In fact, there are entire coral reefs. For those of you who've never seen a beautiful coral reef, you better go as soon as you can, because two things are killing them. Number one, is the increasing temperatures are frying the coral reefs in the oceans. And number two, the increased acidity. There's another thing, the introduction of non-native invasive species are killing them too, but at the rate we're going, we won't have any coral reefs in a couple of decades. Many of them have already been destroyed. And so that's just, you look at California coast. If our ocean continues to increase in acidity, which it will, because it's got to absorb the carbon, then our kelp beds are going to fail. Our fishing industry is going to fail. And we're already seeing that happen around the globe. So I don't know, did I answer that question? We went off in a lot of different directions. Before we go on though, can I just say one other thing?
Yeah.
This sounds so terrible, we're all gonna die. I don't believe that. I believe that just as humans screw up things like we all have done in our lives, we can fix them too. When you make a mistake, you learn from it and you change your habits. And I have faith that we're gonna do that. I just am concerned that we're waiting so long. There's a certain point when we'll go over the cliff, and I don't want to do that. So,
No.
if you're a poor person from a less developed country, you've already gone over the cliff. We're lucky to live here and not to suffer from a lot of these problems.
Here is another question. So here, let's see, let me put it on the screen. Sorry. How come? Because the people learn that the ocean water is salty, but the creeks, the rivers, the water is not salty. So how come rain and rivers do not taste salty like the ocean, considering it's all in one big water cycle?
Yeah, it's a beautiful question. When water evaporates, it's only pure H2O. That's the only thing that's going to evaporate. You're not going to bring any, well, I got to be careful with that, but you don't evaporate salt in the atmosphere. Now, when waves break, they might throw some salt in the atmosphere. When the wind blows over the surface of the ocean, a little bit of salt gets in the atmosphere. But when water evaporates from the ocean, it's mainly just clear H2O. It's as pure as it gets. And so when a cloud forms, that H2O is forming. Of course, it's condensing into liquid water, which might freeze into ice crystals. But it's forming around a tiny, what we call a condensation nuclei, if it's water, or freezing nuclei, if it's ice. That's probably a little piece of dust or pollen, or it might be a little salt particle as well. But even if that water drop condenses around a tiny salt particle, that water drop won't be as salty as the water, nearly as salty as the water in the ocean. So we don't have to worry about that. It's sort of this purification system that's going on all the time. When the water evaporates, pure H2O, so we get that falling from the sky in the form of rain and snow and hail. So it starts out as pretty pure H2O, and over time it picks up the salt. Where does that salt come from? The minerals and the other, there's lots of other stuff, silicon, magnesium, iron. This is from weathering of rocks. So a lot of that salt and other minerals comes from the weathering of rocks as the water pours over them. And that material, those chemicals are carried by the water, still fresh water, we call it, until it flows into the ocean. And all of those, that very less concentrated mixture of minerals and salt that pours into the ocean, we call it fresh water, is stuck there now. And only the fresh water, only the H2O is going to be able to evaporate, and it leaves the salts and the minerals behind. And that's why the ocean is salty, by the way. I hope I answered that.
Well,
Yeah.
here I try to illustrate that while Bill talking about this. You know, you have the runoff. It's in our fresh water, but with less concentration. And that runoff basically bring those minerals and salt into our ocean. But when you have this evaporation, you only evaporate H2O, no salt. So they kind of like stuck in our ocean.
Yes.
Is that right?
Exactly. It's beautiful. Isn't nature, I mean, nature really does a lot of, we forget about her, you know, and she's doing all this work for us all the time. You know, what would our lives be without you know, breathable air and water we can drink and food we can eat? Anyway, this is a great example of that.
Sometimes the river water can come from groundwater too, right?
Yes, that's right. And usually when a natural spring is what you're talking about as an example. And that water has a small amount of mineral content in it as well. All of that has been weathered from the rocks that the water has been flowing through. But it's still what we call fresh water, and its salt content is extremely low, almost negligible compared to the ocean.
Okay, so our next set of questions is about fire and fire ecology. So White Lotus asked, is fire necessary in the state of California for the rejuvenation of native plants, etc.? Fire ecology?
Right, beautiful question. And I think whoever asked this, I bet they know the answer. An absolute yes.
I do.
Yeah, so all of our plant communities have evolved, almost all, okay, I'll say almost. Nearly every plant community in the state of California has evolved with fire. The Native Americans knew that, and they worked with fire too before the Spanish came here. And anyway, what happens is fire will come in, and it may not burn down everything. The way things used to go is a fire would burn warm over the surface, and it would take out a lot of the debris that had fallen on the forest floor or some of the chaparral that needed to burn. And what would come after the fire is that a larger area was exposed to sunlight that didn't get sunlight before. And you have seeds, literally, we have in our plant communities, we have plants that grow seeds that will only break open after they've been scorched by fire and then wetted by rain. Isn't that beautiful? So what that means is that fire is a necessary part of the ecology of our plant communities in almost all of California. And here's the kicker though. These fires, caused by lightning, of course, before there were people, lightning might strike one place and burn a patch of ground, or not ground, but of course, plants. And that would be that. Often it was doused with rainfall. Since there was lightning, there was probably a thunderstorm. Things have changed now, because when people start fires during like Santa Ana winds or examples, they're blown totally out of control. And so they become these enormous conflagrations that are not only burning, you know, hundreds and hundreds and hundreds of thousands of square miles, but they now are burning more frequently. And here's the point I'm trying to make. If you have a plant community that burns occasionally, Like our chaparral in the Santa Monica Mountains averages, it's a huge average with a lot of differences, around 30 years. So once you get in a plant community that hasn't burned in 30 years, it's getting ready to burn. Okay, that's usually the way it works. Now, the problem is if a plant community burns this year and then it burns 3 years later, and then it burns 3 or 4 years later, those plants can't recover. And what we are seeing in the state right now is exactly that. Plant communities are beginning to fail and evolve into different drier plant communities because they cannot recover from fires that occur every 3 or 4 or 5 years rather than every 30 years. And so this is a big problem we have. What a great question.
So I'm putting the Chaparral, California Chaparral Society, their institute, their website, and you can see this is a picture. You can compare before and after the fire. So this is, I think is restoration. This is after.
Yeah, okay, so thank you for pointing. This is really a fun question answer session because every time I forget to mention something, it comes up on the screen. It's amazing. Anyway, so we've got all these problems that may not have much to do with weather. What happened is when we first started moving into California, when the Spanish came here and then the Mexicans took over from them, when we were part of Mexico, they recognized that fires were burning things that they maybe didn't want to burn, you know? Then when the United States stepped in and became a state of the US, we decided that fires were too dangerous. They were burning people, they were burning houses, they were burning ranches down. And so we were gonna stop them. Look, it was a beautiful forest. It provides timber that we build houses with. Why would we want it to burn up? Okay, so we stopped fires in their tracks. This started in the 1800s, unfortunately. And any fire we put out as quick as we could. The net result is that natural fire cycles were interfered with. In other words, what they're saying here on the screen. If you stop every fire, it doesn't have a chance to clear out an area, whether it's every 30 or 50 years. And so the fuels begin to build up over time. And as these fuels continually build up, when a fire finally does sweep through, it burns the hell out of everything. And so it even destroys plant communities by getting so hot that it even burns seeds. So this is another problem we created by first we put out the fires, which we probably shouldn't have. We should have let some of them burn. Now we have this problem where we have all of this fuel that built up. And when the fires burn, they're really hot and disastrous. And now we have this climate change problem and we're building up into these ecosystems and into these wild areas. And we've got a dilemma.
Yeah. So this actually is the next question actually. Gioni asked, can I ask about methods to prevent wildfire from spreading? Or in some cases, maybe we shouldn't prevent wildfire.
Oh, it's complicated. It's complicated. And so let me just start with this. Our wildfires today are really, really dangerous because what happens is someone's out doing target shooting and their bullet hits a rock and there's a little spark. Someone's out mowing grass and they hit something and there's a spark. Someone throws a cigarette out the window and there's a Santa Ana wind blowing, by the way. Just get out of the way. That's all we can do. During our Santa Ana wind season, if you think about this, we have one of the most dangerous fire seasons in the world right here in Southern California because we have a period of wet winter weather that's followed by a long period of summer drought. So when the temperatures begin to go up, it stops raining. all of our plant communities that were growing and happy are now drying out and dehydrating. Right at the end of that drought season, when the soil is the driest and there's the least amount of moisture in the plants, we start having Santa Ana winds. That's the fall season. And you couldn't write a script that could create more disastrous fires than that one. It's just the natural synergy there. It's just the perfect environment to create massive fires. And so what happens is when the Santa Ana winds are blowing at 50 miles an hour and temperatures are up around 100 degrees because of the compressional heating we get from that, and humidities drop below, relative humidities drop below 10%. If there's a fire, you get out of the way. What the fire crews try to do right now is to steer the fire away from developments and homes the best that they can. Sometimes that works, sometimes that doesn't. But you don't stop a fire like that until it gets to the ocean. And we've seen this happen over and over again over the last couple of decades in Southern California and now even in Northern California. You saw what happened in Paradise a couple of years ago, Northern Santa Rosa. That's not the end. That's just an example of what we're going to be looking forward to if, assuming that these climates continue to change the way they are now. So methods to prevent wildfires from spreading. You can do control burns on those moist, calm days, and that's what we're doing in a lot of wild areas. In some places where we stopped fires for so long, we can thin out the forest a little bit. But I want to just emphasize something because it became political a couple of years ago where someone that I don't want to talk about right now started saying that California has a big problem because they aren't taking care of their forests. They need to cut down more trees. Otherwise, they're going to have more fires. And he said the reason why California is seeing all these disastrous fires is they're not managing their forest properly. Well, here's the problem with that. Most of the wildfires in California don't start in the forest, nor do they burn the forest. They start in coastal sage scrub, chaparral, oak woodlands. That's where fires are most common. Those fires that start in forests are National Forest Service lands or National Park Service lands sometimes. But National Forest Service lands, we have no jurisdiction over. It's the federal government takes care of that. Yeah, fire is a natural part of these plant communities. We haven't understood it in the past, we do now. And we understand why we're paying the price for, the combination of not working with nature in the past and now with trying to deal with climate change in the present.
I wanted to ask about preventing the wildfires because I've read some articles about how grazing can help prevent wildfires because they remove a lot of the cheap grass and it can restore the soil as well and it remove excess vegetation and how it could be a solution to preventing the spread of wildfires in different areas in chaparral and in forests and parks and all different areas of California. Do you think that's a solution too?
Yeah, so good point, good question and good point there. And so that's the positive behind that. But here's the negative. Our natural plant communities didn't evolve to be grazed by cows. Cows come from Europe. The Europeans brought them here. And sheep. We didn't have cows and sheep in California or the Western states before the Europeans arrived. So if you bring them in, you're completely transforming it to a plant community that doesn't belong there. And what the Spanish did, and the Mexicans after them, and the Americans after them, is the ranchers brought in non-native seeds from other parts of the world, and so they could graze their animals. the problem with that is that these other parts of the world get more rain and they don't get the summer drought that we have. And so you mentioned cheatgrass, but there's a lot of species of grass that simply, when the summertime drought hits, that's part of our Mediterranean climate. When the summertime drought hits, they go, what am I doing here? I'm just going to die. And so we end up with all this fuel, this dried fuel out there. Cheatgrass is an example, but there are a lot of others. The other thing that you're suggesting, I'm afraid, is that we tear up our coastal sage scrub and chaparral and oak woodlands and just create grazing lands. I'm not sure that we want to do that for obvious reasons.
Well, I read that there used to be a lot of bison, or I'm not sure how you pronounce them, but in North America there used to be a lot of bison, but they were all killed off, and they used to balance the ecosystem and the environment. So
Yeah.
there weren't as many fires because of that. And also goats and sheep do a lot of grazing too, but there aren't that many in the natural environment in California anymore.
Yeah, these are great questions. So about the goats and sheep, we do occasionally use them in California to create fire breaks. This goes back to your question. And you'll see many of those fire breaks up on the hills. If you see these huge stripes of bare dirt that look like roads or trails or something, they're fire breaks. And we have been experimenting with grazing animals to create those fire breaks. It's a great idea. Your question about bison, we never had bison in California. That's on the other side of the Rocky Mountains, okay? So we never had those large grazing animals here. And so we have ecosystems that evolved without them. By the way, if you go to Catalina Island, I think they brought some out there. I think there's still some out there, and a few other places where they were introduced. But we never had grazing animals like that here in California. You know, here's the problem with all of this. Once you start fooling around with nature, there's always a side effect. It's like you take a drug for something and you end up getting sicker, you know, because there's side effects to that drug. So we have to be really careful about how we screw around with Mother Nature's natural cycles. Best to work with her rather than try to engineer her, because usually when we've tried to engineer her, she responds in very violent ways. You don't like that.
Indeed.
But about that question, there may not be an answer to that question. We may have a dilemma where we just have to live with it. Here we are. You know, it's like the COVID thing. The COVID beat us, right?
Yeah, we need to follow the nature's call.
The what is that?
We need to follow what nature calls.
That's right. Nature's talking to us. This is not difficult stuff. She's talking to us all the time, just like she talks to your body. She's talking to us about how we're dealing with all these cycles and systems that we rely on. And there's no secret here. You just have to listen and watch.
Yeah.
She's putting quite a show.
Well, our young people, they actually want to be not just the problem. They want to be the solution to the problem. They don't want to be the problem. So we got a lot of question about engineer, or how to change the situation if we do something. So we know Professor Selby talked about the advantage of solar energy. So there's a question from Gioni. Any environmental disadvantage to solar energy?
Yeah, so every source of energy has a disadvantage. Every source of energy has a side effect. And so what we need to do is to sit down and have an honest discussion and make a list of all the different sources of energy and what we're using them for, and find out what are the best options that we have available. We don't do that right now. We just do things as we've always done them, without any thought about what's best and isn't.
Right.
The thing about solar energy is it takes resources to build solar panels, right? It takes resources to build anything. And so the initial resources that are used to build a solar panel, that has an environmental consequence. However, that's pretty much it after that. I mean, you're just literally getting free energy that costs nothing and that produces no pollution at all. That's for 30 years. And so that's one of the advantages. Now, when you say solar energy, I would argue that those solar arrays that some of you have seen out in the desert are terribly destructive, and they're very expensive, and they waste a lot of energy because that energy now has to be transported in wires to the cities. I think that those evolved because there were large companies who figured out a really easy way of making a lot of money, because we could just put those solar panels on our roofs and been a lot better off. That's just my opinion, and you might hear different opinions from different people. So yeah, you know, there's disadvantages and advantages to every source of energy.
Right. So I know I heard some disadvantage about those solar panels. So I'm putting out a website from Cornell University, their eBird, the website. And actually they use the citizen data. So you and a lot of, bird watchers, they're out there, they submit the data. And we know there's a lot of birds, migrating between north and south, every year. And those solar panels actually can, interrupt how birds sense the direction. So they can, interrupt their migration pattern. So a lot of birds get confused when they fly over those solar panels, because you have, strong reflection from there.
So, Professor, I might be wrong, but I think you're talking about those big solar arrays that we were mentioning, rather than the smaller solar panels on roofs. I could be wrong.
But yeah, exactly, yes.
That's just a guess I have, because when I've gone by and examined those big solar arrays, they scare me. I can imagine what they do to a bird.
Is
that
go ahead, Professor.
Oh, I just say, yeah, that exactly what I want to talk about. Yes.
There's a big, and I just assume that it's for solar energy, but on the way to or from Las Vegas from Los Angeles, and I forget exactly where it is, but there's a huge, there's a few towers, and it's almost blinding when you drive by. So I don't know if that's what, you're referring to.
I am, and that's a perfect example. It's right before you get to the state line.
Mm-hmm.
It's out there in the middle of the desert. It's just terribly destructive, and it's one of the most inefficient green energy projects in the country. Inefficient, because they use the wrong technology, they have to transport it great distances, they did a lot of destruction. That doesn't solve, if you ask me, that doesn't solve our environmental problems by creating more. And so you can see I'm not a fan of those, but I think that, every building that has sun on its roof should have a solar panel.
Yeah, I agree.
There's another question up here.
Thank you.
Well, then how can people in freezing climate do to stay warm without using fossil fuels and still have a reliable system to survive?
Good luck with that. I think that the key here is to use those fossil fuels most efficiently. And so that means that if you live in a cold climate, that you should make sure that your house or apartment is insulated, is properly insulated, so that when you heat it up, you don't lose all that heat, and you keep it inside. There are other things that we can do in construction that cost a little bit more when you build a building, but will save an enormous amount of money in wasted energy over the long haul. So that's how I would answer that question, is just be more efficient in the way we use fossil fuels. And by the way, natural gas continues to be the cleanest form of fossil fuel that we have. And, you know, that's why we're still using it to cook our food in most places at least.
And our, I think it's last two questions. One is any connections to rip current and the rise of the sea level. And there's another one, what about polar shifts or warbles? Does that affect climate?
Okay, the first question, connecting to rip currents. Okay, that's a complicated one because rip currents are caused when a set of waves come in, usually when the waves are larger, and they push a large amount of water up toward the beach. That water has to flow back out in the ocean, and it does in this current. You could probably, if you're a surfer out there or you like to swim in the ocean, you've seen these. They're kind of muddy, dirty looking because they got sand in them and sediment. They look like little streams flowing out into the ocean. They look very peculiar. Anyway, that can happen anytime. And so I don't think rising sea levels are going to make them more frequent necessarily. I think that if we continue on this direction where climate change increases and we continue to warm up and nature has more energy to distribute, then rip currents could possibly get more frequent because the weather patterns are, like the winds are more powerful. So I guess that's a really interesting question. I bet no one's ever asked that question before. I'm just guessing.
Burr, he's a sailor. I'm sorry, Burr, he's a sailor, so he's asking those questions.
That's a good one. Wow, I don't know.
Professor, the reason why I ask that is like I heard you say the rise of sea level on the coasts, and
yeah,
unfortunately we have a lot of rip currents happening in our ocean here in California and Los Angeles especially, like on a yearly basis, and like I wonder why that's like happening. And then I don't know if you've heard about this famous guy died in Venice Beach recently, the WWE wrestler. I don't know if you heard about him. He was caught in Venice Beach actually with this rip currents, and unfortunately he was like washed out after several days. And then I was wondering, like, is it like something new happening?
Well, yeah, no, I don't think so, but I'll tell you, your professor knows a lot about this too, because she's been swimming in that ocean quite a bit. And I will say that I've been caught in these rip currents, if you want to call them that, and they will get your attention. And if you just swim to the side, don't try to swim in, swim to the side and you'll get out of it and possibly save your life rather than be swept out to sea. And maybe this guy didn't do that, I don't know, but when the waves are really big, I stay out of that ocean. I respect it because I know those currents are really strong. You know, you never turn your back on the ocean when you're swimming in it. And when those waves get big, I get out when they're too big. Anyway.
He was like trying to save his son or something.
What's that?
I think he was trying to save his son. I think his son was.
Oh, yeah. Oh, that's happened to me too, where I've tried to help someone and I realized, wait a minute, I'm kind of in trouble now. You know, you're hanging on to me.
Mm-hmm.
Anyway, luckily, I'm still here, right? Now, as I get older, I want one of you to save me. I'm not saving you anymore. What about polar shifts, wobbles? Now, I'm not sure what you're asking. Do you mean that literally the pole is physically shifting, or is this a meteorological thing that you're asking about?
I've read some articles in recent years talking about polar shift. It's like shifting out of its normal position, and it's been affecting the Earth's magnetic field. So I wanted to know if it's also affecting the climate.
Great question. So we have the geographic north and south poles. That's the axis on which the Earth spins. And that's what you study in this class, the tilt of the Earth, right? And how that causes the seasons as the Earth revolves around the sun. That, luckily, is not changing in our lifetimes. You don't have to worry about it, okay? The magnetic poles are changing, which should not have a very significant significant effect on our climate, okay? But those magnetic poles, even, the pole is wandering very slowly. It's not happening fast, and even that is not gonna really affect us in our lifetimes, except your compass is gonna point in a slightly different direction, slightly, as you get older compared to today. So I'm not gonna worry about that so much. You all will have a discussion about the solar winds and how they're directed by our magnetosphere toward the poles, and that causes the auroras or northern and southern lights and all of that. But so we'll set that aside. But I have to answer this question though. Geographically, the Earth's poles are shifting in this way. The Earth's tilt on its axis is changing, right? Okay, so in, what is it, roughly 12,000 years, because the Earth is tilted and is wobbling like a top, in roughly 12,000 years, our seasons are going to be reversed from what they are today. Now it's going to be slow and it's going to be gradual. But this is one of the reasons for natural climate change over the long haul, okay? This has nothing to do with our magnetic poles. This is the literal geographic pole. So the Earth's tilt on its axis, it's wobbling, the Earth is. And so as that wobble continues in space, the timing of our seasons will change. And that in turn will change climates, as it always has over many tens of thousands of years. So that's a geographic wobble that's going on there. And it's very different from the magnetic pole. So yes, in the long haul, that will affect climate, but it's nothing that we're gonna have to worry about in our lifetimes.
Yeah, it's well, this cycle I think takes tens of thousands of years.
Yes.
Oh, sorry, Bill, there's a last question. Could you quickly explain what is urban heat island?
Yeah, that's really important, because what's happened is that when we tear down a plant community and we put in a city, we now have concrete and asphalt and glass and steel. Those surfaces, and by the way, we got rid of the water, because all plant communities, they transpire water all during the day as photosynthesis occurs. And that transpiration of water off the leaf pores of plants, it cools the surface during the day, okay? So when we build a city, we get rid of a lot of those plants and we create this environment that not only gets much hotter at the surface, but you don't have the transpiration of moisture that you had before. And the net result is you don't have that cooling effect. We call this the urban heat island because it gets hotter during the day, and at night it takes a longer time for it to cool off. It's dramatic, and here's some examples. Downtown Los Angeles, the overnight lows average a few degrees higher than the surrounding suburbs, no matter the elevation. And this is true in almost every city in the world. In places like Phoenix, Arizona, where you really don't want it being hotter, right? They're averaging like 5 degrees warmer, at least, than they were before that city was built. And that means that on a summer night like tonight, where they might have had an overnight low of 80, they're now experiencing overnight lows of 85. And this is happening in Las Vegas. It's happening in cities all over the world. And what that means during the summer is that people are going to use a lot more energy trying to run their air conditioners, you know, to cool them off. And that means they're going to heat up the city even more. Isn't that cool? Anyway, it's called the urban heat island. We've measured it all across the planet. And that's the reason, you know, we kind of started off with this, that the gradual warming we've been seeing across the globe is occurring in places where cities haven't grown as well. But in where we have cities, not only are we getting that gradual warming, but we're getting these really rapid increases in temperatures. that are also due to the urban heat island effect.
So I'm sharing with you on the screen, that is a map made by NOAA, the website, showing you the urban heat island in DC, Washington, DC. So you can see the map on now is the satellite image. You can see the downtown area when you swipe over it, overlay it with the temperature map. You will see in those concrete area, built up area, you have relatively higher temperature.
Yeah, Professor, if I could add something.
Yep.
One of the links that I'm sure your professor has or will share with you is the NOAA National Weather Service site, because there is every bit of information about the weather that you're ever going to want, that you're going to get on that site. And what I would challenge you to do is look at the daily high and low temperatures in New York City, as an example, in Manhattan, and compare them to the surrounding suburbs of New York. And it's quite dramatic. The overnight lows are like 5 degrees warmer in Manhattan than they are in the surrounding distant suburbs.
Yes, we have that on our website, guys. Remember, in our in our learning resources, and we have this weather info of Los Angeles, and also the meteorology to let's see, this data. I think it's this one, the first page.
Probably that one. Yeah, I bet it is.
Yeah, probably this one. And you can go any place, across the country, and you can see the temperature.
Yeah. Can I just butt in again here?
Yep.
This is so beautiful that your tax money, by the way, if we got rid of the Weather Service, you wouldn't even notice it in the tax bill. That's how little money they use of our taxes. It wouldn't even be noticeable in the budget of our country if we got rid of them. These folks are the experts. They have their degrees in meteorology. They are the scientists, and they put this information together. And by the way, all of your weather forecasts comes from here originally. The satellite imagery, the maps, the data. What happens is they send it out to the various media, and then the media dumb it down and create cartoons to insult our intelligence. Go to the source. You got to go to the source. It's beautiful. And you will learn. I mean, I taught the class that your professor is teaching right now through most of my career. And I would tell my students, if you go to that source, you will learn far more than you're ever going to learn in a class in meteorology. I guess I shouldn't have said that, but I was saying that about my class, And that is the source of all this information. When Dallas Raines comes on Channel 7 and says, now here's my forecast, it's a total lie. He got all that information from the National Weather Service right here. And he just made pretty pictures and made it entertaining, and
really did make it entertaining.
Yeah, maybe.
I love him. He's so corny.
I would just rather go to the source, though. That's the point.
Good to know, though. Not be fooled by the weather men and women.
I have friends, like they use apps, and they'll come up to me and say, hey, Selby, it's supposed to rain tomorrow. And I'll tell them, there's like a 20% chance of rain for 2 hours. That doesn't mean it's going to rain tomorrow, Just because the app said it was supposed to rain. And don't go to the dumbed down version. Go to the real deal. That's the National Weather Service site.
Yes. Okay. So, well, I see the time is 8:06. Let me stop share first.
Now, you told me we had till 11 o'clock, didn't you?
The whole night. Okay. Well,
hey, can I say one more thing before we sign off? Late night and early morning, low clouds and fog, otherwise mostly sunny in the afternoon. How's that? Someone's got to do a rap to that. I'm going to leave it up to one of your students.
Let's do this. Let's thank Professor Bill Selby coming to our class. It's really exciting to learn so many things about our climate and severe weather, and also how we can, behave appropriately to, adapt to the weather, adapt to climate change, and, to make our future better. Okay?
And I'll just add one more thing. COVID has kept some people inside all the time. And this really bothers me because you're going to find so many answers to your questions about life by communicating with nature. And the way you can do that is to start looking at the sky, and she'll start speaking to you. You just got to listen and filter out all of the fluff and all of the crap that's coming. That background noise is just going to screw you up. Start looking around and observing things, and life will become, hey, you end up kind of crazy like me, but it's fun. You have a lot more fun in life.
Exactly. Yeah. Well, Bill is also my mentor. You know what? When I first came to California, he told me, Jean, look at the cloud. Every cloud have a story to tell. So listen, just listen. That made me cry, literally. That made me cry, exactly. So from there, I feel I'm more grounded and connect to our Mother Nature.
But your professor is also a mentor to me, and I think she knows that as well.
Thanks, Bill. That's my honor to be part of this community, actually. I feel there's a new Jean, after she, moving from Wisconsin to California. There's a new Jean.
You went from a place that had exciting weather to a place that had
boring weather? No.
Yeah.
Okay, are there any quick questions for Professor Bill Selby? Okay.
Yeah.
Thank you.
Thank you. Let's thank you, Professor Selby. If you can turn on your camera to show Professor Bill Selby your big smile, and thank you.
Yeah, thanks everybody. Have a great evening.
You too.
Stay healthy.
You too.
Bye, Bill. Thank you so much, Bill.
Adios.
Okay, guys, that's it today. Let me stop recording.